Hi everyone, welcome to Learning Math with VK. Today we explore lesson 12 in algebra, quadratic functions and sketching using translations. Number one, quadratic functions. A quadratic function has the form fx equal to ax squared plus bx plus c, where a is non-zero. We also have a function gx equal to x squared. This is the parent function. The reason why it is called the parent function because we can use it to sketch any other quadratic function. Let's take a look at how we sketch the parent function. X, y equal gx. X is going to be 3. Then y is going to be a 3 square, which is 9. Negative 2, similarly, we get 4. Negative 1, 1, 0, 0. 1, get 1, 2, get 4, 3, 9. Okay, so we have a set of points here. We're going to plot these points and see what the function look like. Okay, 1, 2, 3. Negative 1, negative 2, negative 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yay, let's do it. First point is 0, 0. I'm gonna go in the middle, right? And then 1, 1, negative 1, 1, 2, 4, negative 2, 4, 3, 9, negative 3, 9. We can connect this point in a smooth curve. And this smooth curve here is the graph of the parent function. Gx equal to x squared. The shape of this curve is a parabola. A parabola. It has a domain and a range here. Domain is, well, if you extend the arrow, you're going to include all real number, negative infinity to infinity. And then the range here, depending on the point that is at the bottom. This point right here, we call it the vertex. For the parent function, the vertex is 0, 0. Range is the value that's on the y-axis. So as you can see, we go from 0 to infinity. Let's take a look at how we sketch the other function using translation. Example, sketch fx using gx equal x squared and identify the vertex. Okay, so we know fx equal to x squared minus 1. That's the first example. Gx equal x squared. This means that fx is gx minus 1. When we take gx, we subtract 1. This tells us that we move the vertex down by 1. So I mean, we shift down 1 unit. Shift gx down 1 unit. X, Y. So here come gx right here. It's the parent function. And then fx, we'll ship it down by 1 unit, -1. It's a parabola. Pretty cool, huh? The new vertex is 0, -1. If we have hx to be x squared plus 1, then the plus 1 tells us that we ship up 1 unit. Gx up 1 unit. B fx equal x minus 1 square. It is the same as g of x minus 1. What we need to do is that we got to figure out the x-intercept. To do this, when there's g of x equal to 0, notice that f of 1 equal g of 1 minus 1, which is g of 0. G of 0 is 0 square, which is 0. So when x equal 1 in the function f, the output is 0. That is when we get an x-intercept. What this means is we got to shift gx to the right 1 unit. X, Y. Okay. So here come the parabola gx. Fx, well, we know f1 is 0, so 1. And it is fx. Shift right 1 unit. Well, if we have hx is equal to x plus 1 square, and the plus 1 is the same as x minus 1 square. Shift left 1 unit. C fx equal 1 over 2x squared. This is 1 over 2 of gx. What this means is that for every output, the output is getting smaller. So we have smaller output. Smaller output tell us that the slope is flatter. Flatter slope. We call this kind of transformation vertical shrink. Visually, this is what it looks like. X, Y. This gx fx, well, flatter slope. Now look like this. Yeah. If hx is 2x squared instead, then the number 2 here is bigger than 1. So we have a bigger output, steeper slope. We call this vertical stretch. D, fx còn negative x square. This is the same as negative of gx. The negative tells us to negate the output. The output of gx are numbers that are on and above the x-axis. To negate that, it's gonna be a reflect over the x-axis. Okay, so this will look like the graph of the parent function. Gx reflect over the x-axis, and we have the graph of fx. Pretty cool, huh? Notice that when we do a reflection, the vertex is the same. Vertex right here, 0, 0. When we do vertical shrink and vertical stretch, vertex is the same, 0, 0. The vertex only change when we do a shift up or down, shift left or right. Vertex is 1, 0, and vertex is for a 0, negative 1. Let's do an example here. Fx is 2x minus 3 squared plus 1. How do we sketch this? The number 2 is tell us to do vertical stretch. Minus 3. No, this minus of 3. So it's just the number 3. Shift right. Three unit plus 1. Shift up 1 unit. Let's take a look. This is gx parent function. So now we're gonna do the vertical stretch, meaning that's gonna get a little thinner, and then we shift right 3 unit, shift up 1 unit. So essentially we are shifting the vertex to the right 3 unit. 1, 2, 3, and to the right up 1 unit. So the vertex gets shifted here. This is the graph of fx. It's thinner because we do vertical stretch. Vertex here is three, 1. So here come the vertex form. Fx is ax minus h square plus k. hk is the vertex. And in the vertex form, it's useful to sketch any quadratic function. Thank you for watching. I hope you found the content useful. Please like and subscribe to help the channel grow. I'll see you in the next video.